joules of heat. The balloon expands but stays the same temperature. How much work did the balloon do in expanding? Okay. So what do you know here? You know a couple things. Yeah, this will be number one. I'll just put it over here. Number one, there's 75 joules of heat. So gas absorbs that. The balloon expands but stays at the same temperature. How much work did the balloon do in expanding? Okay, so you know that delta U equals Q minus W. This is 0 for all of our problems. Q, now it's absorbing the heat. The balloon is absorbing the heat. So if it's absorbed, energy goes in. It's a positive number. So it's 75 joules there minus the work. Okay, so what's the work? The work, if this is going to be 0 here, I guess we can solve this equation, but you can also see that it's just very simply 75 minus what will give you 0? 75. So there's 75 joules worth of work going on in this situation right here. So there's 75 joules worth of work. Number 2 is a little bit more tricky. Number 2, a drill bores a small hole in a 0.40 kilogram block of aluminum and heats the aluminum by 5 degrees centigrade. How much work did the drill do in boring the hole? Specific heat of aluminum is 897 joules per kilogram per Kelvin. Okay, so again, the assumption is that there's no change in internal energy. So if we have this equation right here, again, this is 0. So we're working with Q minus W, right? So what are we looking for? We're looking for work done in boring the hole. Okay, so the heat here, we can figure out the heat. How much work did the drill do in drilling the hole? Okay, so we're working on the drill, and the aluminum is heated by 5 degrees centigrade. And it gives you specific heat of the aluminum. So we can work on that. So we can talk about what the change in the heat is from the aluminum. So for the aluminum, remember our equation Q equals MCAT. Do we know the mass? Yeah, we know the mass of the aluminum. That's 4 kilograms. We know the specific heat. It's 897 joules. It's a very convenient unit per kilogram per degree Kelvin. And we know the temperature change. The temperature change goes up 5 degrees. And 5 degrees Celsius is the same as 5 degrees Kelvin. So we can just say 5 degrees Kelvin there. Great. So we could figure out what the heat is. The heat is from this aluminum block. Great. When you do that, you find out that the heat from the aluminum block is, what is it? The heat is, with the correct sig figs or 2 sig figs, it's this many joules. Okay, great. So that's how many joules are given off. Now, is it into the block or out of the block? The block is receiving the heat, right? Yes, it is. So if we're looking at the heat here of the block, and then we want to ask how much work did the drill do in boring the hole? So if we're considering let's say, here's just like a block, and then there's a little hole here that's being drilled by a drill. Here's a little drill that's drilling it. Okay, here's a little drill, here's a little trigger, and it's drilling, it's going, and this block has a change in heat right there. So this work is doing, this drill is doing work on this block, which then makes this a positive Q. Okay. But the question is, how much work did the drill do in boring the hole? The drill is doing work on this block right here. So we could say that the heat is actually coming out of this drill if you wanted to. by doing this work. And the work is definitely being done by the drill. So it's work being done by the drill. It's not being done on this block right here. So we could say that let's just consider the block here. So if we look at the block obviously there's no change in internal energy in this whole system right here. But in terms of the block, it's this. This is the joules being done to it, and then we have the work right here. So minus the work. So the work being done on the block is that many joules, if this equals 0, right? That's the work being done on the block. But the question asks something a little bit different. The question asks, how much work did the drill do? Well, the drill did, I guess, negative work. So we'd have to say that this is a negative for the drill. It's got to be negative 1800 joules. So how much work it did. Okay, I hope that made sense. It should have made sense. I walked through it fairly slowly, but if you have any questions, let me know. Okay, bye.